Right, let's kick off, shall we? So good morning, everyone. Welcome to the first of many LowCVP webinars, which are designed to provide more information on the electrification of bus fleets in the UK currently. We will be hosting a number of these different workshops over the coming weeks and months, as people are more, some people have more time on their hands, and similarly we can't be engaging physically like we would do normally, but hopefully one day we will return to hosting workshops in specific locations where we can actually go and experience the vehicles themselves and the infrastructure that is being put in, because there's nothing like getting your hands on the real stuff. So I've explained this before, but the meeting is being recorded and will be shared afterwards along with the slides. So if you need to go back and have a look and share with colleagues, you'll be able to do that. Please stay muted throughout the webinar, and please keep your video off as well, just so this prevents any distractions for the speakers. And please use the chat section to submit any questions that you might have. Hopefully you can all use the chat section. If you can't, or if you're having any trouble typing in a question, feel free to email me at daniel.hayes@lowcvp. And similarly, we can follow up with any other conversations that you might have about future LowCVP events or joining one of our working groups in the future. In terms of the agenda today, we've got a presentation focusing on the electrification of bus fleets in London with RATP, ADL, BYD and SSE. And we will then, in the second half of the webinar, be viewing 3 pre-recorded presentations from Mela, Irizar and Hariba Myra, who are going to talk about how they're supporting electrification going forward. So without further ado, I would like to pass on over to Mike Kerslake to start the presentation. Over to you, Mike.
Good morning, everyone. Dan, can you hear me okay, just to check?
Yes, all well.
Okay, so my name's Mike Kerslake. I'm Technical Manager for BYD, who, in collaboration with Alexander Dennis, supply the electric buses.
Commercial bus and fleet responsibility for the UK. We've worked in this project to provide the electrification of the depot.
And I'm Charlie Barnes. I'm the Zero Emission Vehicles Project Manager for RATP Dev London. So I oversaw the recent 94 new electric double deck buses coming in. And I'm here to talk about the Shepherd's Bush bus project. So next slide, please. So our story begins back in 2017 when RATP Dev decided to ambitiously begin their programme of electrifying all 11 bus garages in line with Transport for London's aim to make London, especially central London, ultra low emissions. So all of the Shepherd's Bush kind of project and the electrification work we were doing was geared towards tackling the challenge of catering to TfL's requirements in terms of the ultra low emission zones, as well as providing vehicles that run to TfL specifications. Shepherd's Bush Bus Garage is in central West London, and so the 3 routes we electrified are central London routes, which means that they are very high frequency. There's a lot of high road traffic. Obviously, everyone knows the nightmare that is London traffic and the long queues and how long our vehicles are out on the roads, as well as the high passenger numbers. There's a lot of footfall around central London. A lot of people are moving around and all the challenges that come with that. Next slide, please, Daniel. So just a little bit more about our location. As you can see, we're central West London, around White City, Shepherd's Bush area, just outside sort of City of London. The routes that we've electrified go from Acton kind of area to Piccadilly Circus, Victoria Station and South Kensington. And I've also included a photo of our beautiful bus garage. It's obviously not a recent one because we have a very rich history in a lot of our RATP Dev sites. Shepherd's Bush was actually opened as a bus garage in 1906. So we've been operating there for over 100 years. And we didn't knock the garage down and start again. This electrification project was working with our existing buildings and infrastructure with one fuel lane, a one-way system, 9 engineering bays, and we had to cater to the existing building while we were doing this electrification work. So now Mike's going to talk to you a little bit more about the vehicles that we brought in to do that.
Yeah, so the project covered 3 different bus routes. The first 2 were single deck routes, and we supplied a batch of 36 10.8 metre electric buses for that. Then Route 94, which is a double deck route, was added later, and that had 29 electric double deckers. Both the bus types were developed jointly by BYD and ADL specifically for the UK market. And you can see from the photos that the body style is 100% ADL. It's really just the battery cover on the roof of the single deck that gives a clue that these aren't diesel buses. But under the skin, there's a lot of similarity between the 2 bus types. Both use the BYD lithium iron phosphate battery chemistry, BYD traction motors and control equipment, and they've got the same AC plug-in charging interface. The double deckers do have increased battery capacity and more powerful traction motors compared to the single deck. Now, of course, we can't put batteries on the roof of a double deck, so the batteries are split into groups distributed around the vehicle. So we've got some under the stairs, some at the back of the bus, and so on, in order to minimise encroachment into the passenger compartment. Next slide, Dan. So it's worth dwelling for a moment on the choice to use AC charging. So we offer 3 different charging options as shown in the table on the left. So they're differentiated primarily by power, cost, and space considerations. Pantograph charging is feasible on both single and double deck vehicles, but that's kind of high power technology and it's quite expensive and primarily designed for rapid charging at the end of the route rather than the overnight garage-based charging strategy proposed at Shepherd Bush. So although AC charging is the lowest power rating, it does have the distinct advantage of really compact chargers, and this was really important at Shepherd Bush, where floor space is a premium, so bulky DC chargers of similar power ratings would have been quite hard to accommodate. We've got 80 kilowatts available, so our single deckers can fully charge to that power rating in less than 4 hours, but really 3 hours is a more practical, typical charging time because we wouldn't plan a schedule where we could discharge back from 100% to 0. Some will definitely take a little bit longer because they've got bigger batteries, but the key question is not how fast the bus can charge, but it can charge the available time. So,
sorry, Mike. Sorry.
Yeah.
We're losing you a little bit. If you maybe just speak.
Yeah. Is that better now?
It is, yes.
Yeah, so okay, we had this in the rehearsal. So if that happens, interrupt me because I think when somebody else cuts in, it seems to get better.
Okay.
just okay. Cough or something.
Yes.
Yeah.
Listen.
Yeah. So yeah, the double decker's got larger batteries. They do take a bit longer, but a bus that comes in at midnight and leaves at 6 a.m., you've got a 6-hour charging window, and we're talking 3.5, maybe 4 hours charging time. So if we can fit within the available window, there's no point in going to a high power system. There's regulatory limits that prevent us exceeding 63 amps per connector with an AC plug-in connection. So we actually have 2 cables for each bus. So actually plug the vehicle in twice, and in the picture you can see the 2 cables going from the charger to the inlet on the vehicle. You can also see the charger closer to the camera. The twin cables go across the back of that bus, and they're actually plugged into the bus next to it. So we can do 2 rows of buses from one charging gangway. The chargers can be operated as standalone units, but a bigger installation like this usually makes sense to control them via a local network. So we get to the next slide. So deciding how to manage the charging and working out the power requirements of the garage is the key thing. We start with the route schedule. We use that to model the battery power requirements, battery charging power requirements, and that based on vehicle energy consumption. That's based on the mix of track testing, lab testing, and real-world performance monitoring, and then we take into account route speeds and weather and so on. So that gives us a site power demand curve, which is that orange just to the right of centre. So we allow a bit of time for going through the bus wash and parking, then the bus starts charging. And that gives us a power demand curve, which is very heavily driven by the vehicle schedule. So what we can do is manage the shape of that curve if we want to using our charging management system. So we might want to reduce the peak or move some of the charging into a time when you get peak electricity. We'll come to that in a moment. But the final thing to mention on this slide is we can also predict electricity use. So the operator can start to scope out what their likely power requirements will be. Next slide, Dan. So here on the left, you can see the model power demand driven by the vehicle schedule. And you can see that in the late evening period, I don't know if you can see the numbers there, but it's around about 8 to 11 p.m. There's this initial peak where the early running buses start charging. The red line is the power limit at the site. And at this particular site, they're permitted to take a lot more power at night than during the day. And you can see our charging demand in that mid-evening period goes well above the available power. So on the right, by using power charging management, we can delay the charging of lower priority buses. That's maybe buses that aren't early run out the next day. They can afford to be charged a bit later. We delay authorizing those to start charging until after that 11 o'clock point, when the predictable power demand can go much, much higher. So you can see we've skewed the graph to fit within the red line. Next slide, please, Dan. This is what it looks like at the site. So on the left, that's the foreman's office at Shepherd's Bush. So on the supervisory computer on the desk there, and what they've done there at that site is put a big screen on the wall which shows the real-time display of all the chargers in a simplified site layout drawing. So you can see which vehicles are charging, which chargers are occupied, if there's any faults or anything like that, and you don't have to walk around the yard and check what buses are doing and the state of charge they've got. So I'll hand over now to David from SSE, who will talk about the electrical installation work.
Okay, next slide, Daniel, please. Right, so the first step in electrifying a bus depot is to understand what capacity it requires. And the graphic I've put top left illustrates the modeling tools that we use to understand the impact of, for example, smart charging over simple charging. As Mike's mentioned, smart charging has the ability to schedule when the buses charge, so we can build a consumption curve for the day, and that will give us our total capacity required. In this particular case, we then go to the DNO to request that capacity. In this case, the DNO was UKPN, although going forward, SSE is now being granted an IDNO license, so it can actually perform the function of a DNO anywhere in the country. We need to consider diversity, so the bus depot's charging system is resilient to failure, and you'll see in the two graphics that I've put in, there's actually two HV transformers here coming from the grid into the Shepherd's Bush depot. We also consider the metering and how our modelling tools can actually help the bus operator understand the cost of energy going forward, essentially the OPEX of running the electric buses. Shepherd's Bush itself is not a private network, although if there is an aspiration for any bus operators listening to deploy behind the meter generation, for example, solar, distributed energy storage such as batteries, that's a useful option to consider. So we'll now move on and look at the next step, which is devising the parking plan. Daniel, could you switch slides, please? Right, so with 100 or so buses at Shepherd's Bush, initially not all of them are electrified. So this is a mixed fleet. We've got electric and diesel buses operating from the same depot. And it's very similar to many London depots in the fact that space is quite severely constrained. So we have to come up with a parking plan so that, given the bus time of arrival in the evenings and time of departure in the mornings, buses don't block each other in. Adding electrification adds an extra layer of complexity, because obviously electric buses can only park where there's a charger. You've also got to consider the turn radius as well to make sure that buses can maneuver safely within the depot, and also your future electrification plan. So given a parking plan that you see there, you'll see the different chargers. Those are the coloured boxes. Next to each one, there'll be a bus charged in the evening, and the colour coding is indicating which low voltage switch panel serves those individual chargers. So if we go on to the next slide, you'll actually see a low voltage switch panel. That's the middle graphic. There are 3 of these in Shepherd's Bush, and they basically, in a star configuration, distribute the low voltage supply out to the various chargers around the depot. Now, one of the defining features of the Shepherd's Bush garage is the way we have used overhead low voltage cabling to distribute energy around the depot. This is particularly helpful because it minimises the amount of disruptive civil works that have to go on. It's also very flexible, and given that I've mentioned it's a star network, you'll be able to see how we've used overhead cable trays to route quite a large number of cables to be able to distribute energy down to a charging island. And that charging island, in addition to essentially being the termination of that ceiling cable tray, provides the chargers and also Armco barriers to protect them from any inadvertent bus movements. The Armcos also actually provide a useful means of distributing cable across the depot floor in a safe manner that doesn't require a dig and duct infrastructure. So basically what it makes for is a nice, clean and easy implementation that can be deployed relatively quickly, which is important for keeping a depot that, generally speaking, doesn't stop operational. So I'll hand over now to Charlie.
Cool. Next slide, please, Dan. So as you've heard, a lot of technical wizardry has been going on in the background. From the kind of operator's side, we were involved in all the decision plans going along and the design and optimization. But the main thing we were obviously worried about when it actually came to it was how we're actually installing this stuff. And honestly, the key thing was the teamwork, regular communication with especially the SSE team as they were implementing all of this stuff on site. There was a minimal impact to operational service. We didn't lose any miles. No vehicles were prevented from going out. We had to do a few changes in run out, occasionally change where vehicles were kind of parked, or look at barring off certain areas for parking at night or during the daytime. But otherwise, it actually ran, amazingly smoothly, and real shout out to SSE's team and also the site team at Shepherd's Bush for assisting with that. I think definitely the flexibility between both teams, kind of understanding and accommodating how to work together, was really key throughout the whole thing. And especially as David mentioned in SSE's design, there was no ducting underground. They didn't need to do heavy groundworks. It was mostly around the edge of the depot, which made our lives so much easier because at the end of the day, we still need to park all 120 odd vehicles on site every night. And the way SSE structured their work and did that allowed us to do that without a problem. So I guess one of the kind of key things I took away from the experience is that it's just so important to ask the right people the right questions at the right time, so that you know exactly what's going on both day by day and in the coming weeks and months, so you can start to put everything in place to kind of work towards that. I mean, that ultimately everyone just is able to crack on with their day job, which we were able to do fantastically, which made a huge difference. Next slide, please, Dan. So the overall result, absolutely loads of positives. One of my favourites is 63% of the drivers explicitly prefer driving the BYD EVs over hybrid and diesel vehicles. It's a mixture of they really appreciate the positive impact on the environment, to they really enjoy the handling, the amount of control they get using the accelerator pedal, and honestly just the power in the motors to be able to accelerate the vehicle so smoothly from stopping. On top of the driver's side, we also saw from the engineering side a significant reduction in mechanical loss mileage. The only thing we've really seen on the vehicles, and now they're reaching a couple of years old, some of the single decks, is the standard kind of doors and the automatic ramps, which we have in London. They all play up occasionally, and honestly, that's pretty much it. It's had a really positive impact on our service and able to meet those requirements. Another bonus is the reduction in fuel costs. There's obviously a change to the way we now sort of, in inverted commas, fuel the vehicles. We don't need to necessarily put them through the fuel bay, but we put them through the wash, so a lot of them come in the same way. So run-in is very similar in that respect. It's just making sure that we kind of park the electric vehicles up where to charge where they're needed and leave space for the diesel vehicles, which has meant a little bit logistics for the night crew, but they've handled it very smoothly. And I guess a lesson learned from that is the higher proportion of electric vehicles, the easier, because you have more charge points, therefore you have more options available to you. Rather than if you have a smaller amount of electric vehicles, it's making sure they run in at the right time or you leave space, they can access those charge points. And significant reduction in fuel costs because of this. We need pretty much half the amount of diesel we ever did, and now we're using a lot more electricity, which is a lot cheaper, and you can kind of benefit from nightly cheaper tariff rates when less people are using the electricity and the benefits that go with that. A bonus as well of the electric vehicles is less noise pollution. They are, to be honest, dead silent, which has actually proved to be too effective that in London it's raised awareness of how people do often rely on listening to cross the road. So we actually work with TfL for the Route 94 with launching what's called the AVAS project, which is Acoustic Vehicle Alerting System. It's currently still a trial on the 94s and a couple of other routes in London, where when the vehicles are driving under a speed of 15 miles per hour, a slight additional noise is made because the vehicles themselves move so silently, just to make sure people are aware of their presence, to assist the hard of vision, so that people are just more aware of the vehicles and to improve safety, basically. So it's interesting, there's new technology arising with the electric vehicles that we're currently trialing to kind of keep improving it, basically. One of the kind of, I guess, very few challenges we struggle with, but we did our best to minimize it, was losing parking spaces due to the additional installations work. Thanks to SSE's design and the space we have at the garage, we didn't lose any due to all the additional transformers, low voltage switch panels and the like, but purely due to the fact that chargers have to be on the edge of the depot and the Armco we had to install to protect them for safety. We lost, it was about 4 parking spaces out of 120 during the first phase when we electrified the first 2 routes. But then during the second phase, when we did the 94, because we'd already kind of done the painful bit and we were very familiar with the way we were parking then, there was no additional parking space losses, which is significant to us because, as everyone knows, parking spaces are key to buses, which are key to our income. I've specifically included the photo of this design in the slide, is because this is one of the strangest things that a lot of visitors to our depot notice, is during the day, it's basically just a bizarre triangle shape that kind of slips out into the edge of the depot. We specifically did that because through working closely with the night team that do the shunting and SSE and understanding our parking layout, that fits perfectly to allow 6 buses to park in that space. So 2 either side of the triangle and actually 4 kind of in front where these 2 chargers are. They charge the centre 2 and there's 2 more out of camera shot to the side. And so it's one of those where when we're confident how everything fits together, we can make sure that we work with SSE to cater exactly to our parking arrangement. As bizarre as it might look during the daytime, as anyone that works with buses know, nighttime depots look completely different landscape, and it's how you cater to that. Next slide, please, Daniel. So as I've already kind of touched on, the key lessons learned is definitely understanding some of the wider and long-term effects of design and installs. When you install something, how will it affect especially the night teams and the shunting and the vehicle movements, but also how people will use it during the day and any other intentions. We've had issues because part of our bus depot is open to the public and it's on a public road. It's understanding how the public would also possibly be able to interact with those chargers and any risks associated with that and understanding them. And then on from that, understanding the effect on the teams, roles and processes and how we're basically going on to business as usual as a bus garage. And Shepherd's Bush has been a fantastic trial with this. As I said, we're planning to roll it out to other remaining 10 bus depots. So it's been a fantastic learning curve with the local team, is understanding what we need to put in place to make it business as usual. and how we disseminate the key new information. Again, SSE and BYD have been fantastic in providing resources of not just, here's your equipment, it's installed, it's how we maintain it going forwards, what we can do to minimize any impact, how we can preserve the equipment, any ongoing maintenance, especially with high voltage equipment, which is very new to us as a bus operator. It's key that we put the appropriate safety training and processes in place so that it can, as I said, become business as usual, as this is what the new industry looks like. So I guess finally, the absolute key thing is capitalise on the available expertise. It's been fantastic working with BYD and SSE and understanding their knowledge, being able to take from that and share it with them, and use it to make sure that we absolutely capitalise and optimise everything we're doing at the garage, to continue working with them and having a very smoothly run operation, which started in February of '94 with no issues, and the buses are now running really well. So it's been a joy of a project to work on. Next slide, please, Daniel. So that's everything from us. Thank you, everyone, for listening. I hope you found it useful. And as Daniel was saying, we're happy to take questions.
Great stuff. Thank you very much, Charlie. And apologies for the audio connection there, that we lost Mike for a bit, but hopefully we'll get the captions up on the recording, and we'll be able to capture what Mike said there. We've got a few questions in. Why does the depot need 3 transformers? Were there any grid constraints? I don't know if that's one for you, David.
Usually there are grid constraints in London. They normally are put in there to provide diversity, which in turn provides a degree of resilience to the supply to the depot.
Excellent. Okay, one for you, perhaps Mike, or maybe Charlie. Why do electric buses in mainland Europe tend to need pantograph charging at the terminus, whereas nighttime depot charging is sufficient for London buses?
It's probably a question for the European operators more than for us, because we would contend that that's a more expensive solution, and it means you can't leverage off-peak electricity, which is also tends to be greener in the UK, at least, depending how you measure it. It might be that the dominant manufacturers in the European market don't have such a good supply chain to batteries. We make our own batteries, so we've got a very substantial and robust supply chain for getting large battery capacity. Potentially, it's because they don't have that supply chain capability. So the incumbent manufacturers tend to prefer strategies which use a smaller battery charged more often. But our belief is it's generally more cost effective and matches your traffic requirements better to charge at night only. In some cases you can't do that, but for schedule requirements we think it's sufficient.
Okay. Charlie, did you?
Yeah, sorry, I was going to chip in as well. Partially it's also due to the London market. It's a little bit unique in the way that we cater to TfL as our customer, so we follow their specifications, and currently their specification is no en route charging, in part because there's very little space in London, and I believe when you have pantograph charging on the street, usually the associated equipment is about the size of a shipping container. The way London operates, there's not currently a lot of space that's freely available for equipment such as that. So it kind of benefits us to do it in charging and keep it separate, because the way the market works as well, with TfL operating and multiple different operators on their behalf, it's how that works. But it's something they're investigating, so could change in the future. It's just for now, it seemed a lot more straightforward to implement it this way.
Yeah, there are also planning constraints for pantograph implementations in cities, so that's another factor to consider as well.
Great stuff. A couple of questions on the construction. How long was the construction period? Did it stay within budget? And similarly, did the connection to National Grid go to plan? I'm sure you've heard this before, but there's been many challenges around connecting to the grids. How were the response times and engaging with the local DNO?
I wasn't actually the project manager on this particular implementation, so I don't have the colleague with me that was involved. I don't believe, unless Charlie wants to give me any more information, that there was any issues.
I honestly also only worked on the recent 94 project. The earlier phase, I was around the business but not doing it. However, I believe it was fairly smooth, and because we knew we were phasing the project and looking forward, it actually minimised sort of working with the DNO to make it more efficient, because when BYD modelled the initial 2 routes, they also calculated a bit of extra capacity and what we'd need if potentially electrifying the whole depot. So because we had the grid connection initially done in 2018, when we started the second phase project mid last year, it meant we didn't have to worry about any of the grid connections. We just put a bit of extra on-site equipment to make it more efficient. But UKPN was our DNO connection provider, and we found them really straightforward to work with. I've had no issues with it, and I think it was successful with the previous project as well.
The dialogue with the DNO is really important. So I don't know if you can click the slide at 7 again, Dan. That showed the huge difference between daytime and nighttime electricity availability. Hopefully, if you just press 7 enter, with 7 enter, it will take you. That's the one.
Okay.
Yeah. So you can see at the red line, you've got massively more power available at night than daytime, and you need to have a good dialogue with the local network operator to understand if there's an opportunity for that, because by default they'll tend to give you a flat line a curve, and there might be a big opportunity at night which isn't immediately available.
Mm-hmm.
Great stuff, Mark. Mike, one for you. A couple of questions about the energy consumption on the bus of the auxiliary systems. Someone's asked, what's the HVAC system used, and what is the draw on the battery for the lighting and other audiovisual electronics?
Well, we don't have a breakdown to break out the general accessory loads, but we do in the model and in our monitoring look at HVAC loads. So for these vehicles, base vehicle energy consumption, not including HVAC, is a little better than 1 kilowatt hour per kilometre. The original specification of the single decks was diesel heating, but they are being modified to a resistive electric heating system. So their energy consumption is going up. We've only got a small number of those vehicles modified so far, and we've had quite a mild winter. So it's a bit difficult to say what the impact of that would be. But in our model, we've got assumptions of what we think the power consumption would be. The difficulty with heating is that it's kind of more of a steady power demand than a mileage dependent power demand. So the calculation has to allow for that, and it means it's quite speed dependent on different routes. But it likely push up the energy consumption for around 0.9 kilowatt hours per kilometre to perhaps 1.2, that sort of range. The double have a heat pump system, so that's a lot more efficient. Again, we've only had limited winter running in a fairly mild winter, but we've seen really good results, around 1.25 per kilometre, and very little effect from the heating so far with vehicles running this winter in London.
Great stuff. We've still got quite a few more questions, but conscious of time, I guess we'll take one more that's quite an interesting one. Is there's a perception that EVs require less maintenance and resource than a conventional diesel bus. Charlie, I guess have you experienced this to date in terms of reliability and availability?
Definitely, as I said earlier, with reliability in terms of mechanical loss mileage, that's gone down a lot. We very rarely need to, once an electric bus is out in service, need to kind of bring it in because of any faults that have developed while it's on the road. We've also found, when honestly just chatting to the engineers at the depot, asking them how they find it, a lot of them say they still have barely seen the vehicles, even though they've had some of them for up to 2 years, because they only see them every month when they do the very minimal standard, checking everything's fine, the monthly inspection. So because we haven't had any significant faults or anything yet, they haven't even had to get their teeth into any serious diagnostics yet. So I think that speaks to the fact that they haven't had to do too much work, and they're still running very smoothly without a huge amount of input from us, which is a bonus.
Great stuff. Okay, we've still got quite a few more questions, but I'm afraid I'll have to leave it there and move on to the next section. We will be making the slides available, and we can have a follow-up conversation as well with everyone. So thank you very much, David, Charlie, and Mike for that. I'll now be moving on to what LowCVP are setting up is our suppliers portal, where we will be hosting a number of members who are supporting the electrification of bus fleets in the UK. And we will see a selection of those members now. I've got a couple of presentations to show you, so I'll just switch over to present that now. So if you just bear with me. Excuse me. Okie dokie. Apologies for this.
Overall, welcome to this 5-minute video which has been produced by Mellabus to inform bus operators and transport authorities applying for funding under the Bustown Electrification Funding Programme. Overall, this video encompasses the presentation of 2 size-appropriate electric buses and the context in which we are planning to offer these products to the market. Mellabuses are designed to support future public transport operations changed by disruption and emerging ticketing technology. Our buses are designed in the same way as larger 22-seat middies to deliver on the 4 key design inputs. These are service flexibility, environmental sustainability, operational integrity, and customer experience. Transport authorities can endorse Mellor electric buses because they feature DDA-compliant low floors with single-step access that ensures no one is left behind. Service operators can use Mellor buses with high-density city environments to support first-mile, last-mile services as part of a hub-and-spoke model. When we examine passenger transport's current trends together with emerging markets, it is clear that between the 4 main transport solutions, social transport, hail riding, private hire, high-capacity public transport, there is a gap for a new kind of transport, the so-called on-demand responsive transport. We are living in a time when, compared to other road users, the use of public transport by bus will continue to decline. However, given the likely blurring of private hire vehicles, taxis and demand-responsive transport, a future that combines these old and new transport options is increasingly expected by Mellor and government studies. This is the space that Mellor targets, highly accessible buses that can deliver stage fare as well as DRT services. Mellor buses want to support both private and non-private operators to introduce buses that will enable a positive shift in their business models, growing revenues by improving flexibility, access, user experience, and costs. DRT services are able to feed into main transport networks as an extension to their existing services. A fleet of appropriate sized buses can be dynamically reassigned to different operating modes, such as a fixed route mode, a taxi mode, or a rideshare mode. Mellor small buses can increase transport density while pushing the benefits of more significant bus aggregation. It is essential that all bus types, big and small, integrate to ensure that DDA and single-step access is common across all types of service provision. This is not possible using a high-floor standard light commercial vehicles. With all disruptive transport, it is passengers that create the demand because of positive user experiences. Mellor believes that operators using the significant government or industry stimulus can promote these ride-sharing solutions similar to those seen in Hamburg, Helsinki and Lisbon, where simulations have driven decreases in congestion and CO2 emissions and improved air quality. Digital connectivity and infrastructure are critical for innovative passenger services to be cost efficient and successful. Mela buses give operators that first mile, last mile access to passengers utilising digital platforms, increase the reach of ride sharing and stage fare demand responsive services, and enhance the independent mobility of people in rural locations. Local authorities such as Milton Keynes are also actively pursuing the concepts of an integrated emergency, taxi and bus solutions to aggregate some special purpose transport vehicles into the broader demand responsive market. All Mela buses presented are built to meet the exacting and demanding standards of both the private taxi and public welfare cohorts. To target the previously described markets, Mela developed two electric vehicles, the Orion E and the Pico. We believe that in the context of the future bus provision landscape, the introduction of appropriate sized buses is public transport's best chance of meeting new levels of customer expectation and need. The Orion E is one of the most advanced all-electric small buses with zero emissions manufactured in Europe. This flexible bus solution is designed to be a key component in the fight for clean air. In addition to that, its flat floor runs from front to back, delivering highly configurable layouts. Depending on the class of bus and user specification, seats can be fixed or removable. The custom electric motor drives the Orion E along the most challenging routes in all weather conditions, anywhere in the world where bus services operate. The Orion has a 100-mile range on a single charge and can carry 16 passengers or 15 passengers in a wheelchair. The ultra-low flat floor is accessed via a DDA compliant single step or by using the integrated boarding ramp. Flexible charging options are available. The Orion comes with a 33 amp onboard charger as standard for Type 2 connection. A 66 amp version is also possible to fully charge the bus in under 2 hours. The Orion E is sold both at home and overseas and is available to order and demonstrate now in right or left-hand drive variants. In 2019 at the Bus World Expo in Brussels, we introduced the Pico. This bus is based on the Fiat Ducato platform and is especially designed for the emerging DLT markets. With its innovative all-electric drivetrain and class-leading 250mm step height, the Pico can lower operational costs within DLT environments while providing full DDA compliancy to passengers. Like the Orion E, the Pico features a fully flat floor and therefore makes the vehicle highly configurable. In progress is currently the development of a hydrogen range extender with one of the key players in the European vehicle market. Every vehicle we manufacture is built to deliver excellence in passenger and operator experience. Above all else, our innovative products provide efficient, accessible and sustainable transport solutions. Please contact us at the address below. Many thanks. Goodbye.
Great stuff. So that was Steve Reeves from Mela. I'm now going to move on to Hariba Myra, who are offering a retrofit solution for existing diesel buses.
Hi, my name is Greg Harris from Hariba Myra. I'm here to talk to you today about our offers for electro retrofit solutions for diesel buses. Whilst there are many new electric buses available in the market for UK operators, we believe that because of the size of the UK fleet, the vast majority of those buses being diesel and the UK's timetable to move towards zero emissions, there's a significant requirement to look at an alternative. So today we're going to present to you the approach for retrofitting some of those diesel buses with electric powertrains. So Myra is working with some key partners to offer what we put forward as an OEM level retrofit. So using components from key suppliers that already provide components to other bus manufacturers. So you're getting the same level of components and a high quality engineering program from Hariba Myra. So for those who don't know Myra, we're a UK-based engineering consultancy and testing business. We've been around for more than 70 years. And although we're most known for testing, the engineering side of our business is about 50% of our revenue now. We've also been working on electrification for more than 10 years, particularly programs on heavy-duty commercial vehicles and buses as well. One of our key partners is BMZ Group, so the battery being the heart of the electric vehicle and also the area for most concern. We've chosen to work with BMZ, who are Europe's leading independent battery manufacturer, and also have extensive experience in supplying batteries into electric buses. Our other key partner is Zeil-Abeg. So Zeil-Abeg are maybe not so well known in the UK, but they're a very well-established manufacturer of electric motors for a variety of applications. And in particular, they've developed integrated e-axle. It's very efficient and compact, and they supply that to a number of bus manufacturers across Europe. So by bringing together the expertise of these suppliers and Myra's own experience, what we can provide is a solution that really maximizes the zero emissions range of the bus. It provides a high level of safety and provides a good balance between value and price, offering a very high quality solution, but at a lower cost than buying brand new buses. And we can also bring in smart diagnostics and live monitoring technologies and offer that as part of the overall retrofit solution. So looking at what we can provide it's a turnkey solution. So Myra is doing the engineering, we're working with the suppliers for the key components, and then we're also working with specific UK delivery partners from the bus industry who will be able to actually undertake the conversion under Myra supervision. So this means, you know, people that are used to working on buses benefiting from our experience on developing electric powertrains to offer a complete solution. And the warranty and first line support will come from those delivery partners, backed up by Myra and our partners as well. As mentioned, we can also provide this smart monitoring and diagnostics through our partner, VeriCity. So it's quite well known and established in the industry and used by a large number of OEMs, mainly on electric buses, to help provide this real-time monitoring capability to provide the most efficient and reliable solution for bus electrification. So, in summary, we believe that retrofit can be the best solution in many cases. It allows operators that have invested huge amounts of money into buses but now need to move towards zero emissions to maintain a lot of the value in those buses. We believe it's a very competitive solution. There are significant cost savings compared to buying new buses. It provides lower overall operating costs once you take into account the fact that the reduced purchase costs of the bus. It can also be more flexible, so we can design the solution to meet the range requirements of your particular routes, and also build in the timing for those retrofits to suit your own requirements. And along with that, we can also provide leasing if that's a preferred option for you. So in summary, we'd be very happy to speak with any operators that would like to find out more about what we can offer. My contact details are on the screen, and hopefully I'll be presenting this as part of the LowCVP webinars going forwards. Thanks for your time.
Great stuff. Thank you very much there, Greg. And finally, we will now hear from Irizar talking about their e-mobility solutions. So let me just get that loaded up.
Welcome, and thank you for your interest in Irizar e-mobility. Irizar e-mobility is part of the Irizar group based in northern Spain. We have 13 production plants with 3,500 staff across 5 continents, and last year we celebrated our 130th anniversary. As an employee-owned cooperative, we have strong financial solidity. We offer a wide range of vehicles, from electric buses to integral coaches, with many of the components developed within the group, including Mesats, who specialise in door and vehicle access systems, and Hispacode, who provide climate control technologies. In 2014, Irizar Group decided that electric mobility would play a significant part in the future, and invested 75 million euros building Europe's first electric bus factory. The factory was built to ensure it is eco-sustainable and has a Class A energy efficiency certificate. The facility has its own test track to ensure that every bus leaving the factory meets our exacting quality standards. Irizar e-mobility has 3 distinct product ranges. Firstly, the IE bus. Incorporating new innovations as well as new battery technology, the vehicle design has been optimized for passenger capacity and comes in 10.5, 12 and 18 metre versions. Secondly, the IE tram is a real head turner. Having received the European Bus of the Year award in 2018, and when used alongside intensive bus priority, the design gives her the look and the feel of a tram system for a quarter of the cost. These are available in 12 and 18 metre versions. And finally, the IE truck, a truck designed for urban use and will initially be employed for refuse collection. The buses are built with a stainless steel frame with bolted modular aluminium structure and a flat floor throughout to maximise the space for standing passengers. European source components give operators familiarity with the common components used across their own fleets. 2 technologies are offered for our lithium-ion batteries, allowing either slow overnight depot charging or regular fast charging at the terminal points during the operating day. Efficient batteries combined with a regenerative braking system reduce energy consumption and maximise vehicle range. The roof-mounted battery modules ensure optimal use of space, thus safeguarding more passenger capacity, and future-proof the bus for advances in battery technology. Our slow depot charge bus with a 350 kilowatt battery pack offers autonomy of around 250 kilometres. Our ultra-fast opportunity charge bus with a 120 kilowatt hour battery pack offers a range of around 60 to 70 kilometres between fast chargers and can operate for a whole day. We offer 3 charging solutions: ultra-fast opportunity charging with Panto up, which means the Panto is located on the roof of each vehicle. Ultra-fast opportunity charging with Panto top down, which means the pantograph is located on each charging mat at terminus point. Both these solutions are recommended for intensive routes with high daily mileages, allowing buses to fast charge in less than 10 minutes at loads of up to 600 kilowatts between journeys. And finally, slow charging, the most traditional way of charging, which involves plugging the bus in, usually overnight with the bus out of service. The vehicles are charged by using Irizar Group chargers, ranging between 50 to 200 kilowatts. All the Irizar DC charging systems are interoperable with other European manufacturers, and smart charging between buses can be used to optimise the peak power needed within the depot. Irizar electric buses are already a reality, with over 250 operating across Europe and orders for another 150 during 2020. This slide shows some of our customers who operate both depot charge and opportunity charge buses, both in Madrid in Spain, Amiens and Aix-en-Provence in France, and Schaffhausen in Switzerland. Our largest project to date is in the city of Amiens, which went live in July 2019. 43 18-metre articulated fast-charging IE trams operate daily over 3 BRT lines, with high bus priority and fast charging stations at the terminal point of each line. The operation is supported by Irizar with a bespoke 15-year repair and maintenance contract for the entire system. So why choose Irizar as a partner? Irizar e-mobility was founded with the aim of providing comprehensive European electric mobility systems for towns and cities, manufacturing a versatile range of electric buses and infrastructure systems. All buses and chargers have been designed and manufactured using group technology and come with the Irizar guarantee of service quality. The operator, therefore, has the benefit of a single point of contact at every stage of the project, from project planning and delivery through to service and support, which are tailored for the customer's needs. Whilst providing the operator with an attractive total cost of ownership and proven track record of project delivery, you can be assured Irizar offers a full turnkey solution. Thank you for your attention. If you would like to discuss our products, please contact me directly via email or by the numbers on the screen now.
Great stuff. So thank you to Sean, Greg and Steve for those presentations. I'll just jump back to the slides. We now have an opportunity for people to ask Steve, Greg or Sean any questions that they might have. I'll just have a quick look to see if we've got anything. Sean, I don't know whether you wanted to pick up any more on the discussion around opportunity charging in the UK.
Dan, can you hear me okay? Yeah.
We can do, yeah.
Yeah. Yeah, I mean, only on the fact that there'll be a number of transport authorities that are expecting that some routes will need to be pantographed in the future. Really. So, I mean, we are currently sort of discussing with people, with certain authorities about that.
Okay. Question here on what's your ratio in terms of replacing buses in terms of diesel buses like for like with electric? Is it comparable in terms of fleet size, or do you need more buses?
Sorry, is that aimed at me? Sorry.
Yes, that was you, Sean. Sorry, yeah.
Yeah. Yeah, I mean, if you're doing sort of fast charging, opportunity charge, you're usually around 1-to-1 at the moment, and maybe then I think on depot charging you're looking at probably 2 or 3 more in a fleet.
Excellent. Okay. Greg, if you're there, we've got a question for you. What bus models have been retrofitted so far, or I guess what bus models are you looking at retrofitting in the future?
Yeah, so we're right at that time at the moment of trying to engage with the operators to understand what the most suitable models would be for the UK market. So whilst we've been working with our partners and starting to engage with some operators, obviously we want to get the best picture possible of where the demand would really be for this. And we do see that there, particularly with double deckers, you've got obviously limited number of options. It's very much focused on the UK market, and therefore and also there's a high cost associated with the double decker. So that's something we're definitely looking at in detail now, is the options around retrofitting double deckers. So I think the question there really is what we'd like to see is input effectively. What would be the best target for us to work on? So that's really the situation right now.
Okay, so you're looking for operators to partner up with effectively.
Yeah, I mean we're looking at different routes. So we're looking at some potential to do some collaborative project to develop that solution. We also have some internal funding available to do that. So it's quite an open discussion really about how that will be developed. But there is an opportunity for any operators that are interested in this to engage with us to get their input into what solutions should look like, particularly in terms of the specific bus models, the type of range requirements that they have. So we can make sure that when we build, obviously we then build a demonstrator which can be trialed. So we want to make sure that we get it right, basically.
Great stuff. Thank you, Craig. And Steve, one for you. Where's the biggest demand coming for your products at the moment in terms of the Pico and the Orion E?
Scandinavia is where we're seeing the most interest in the smaller Pico type vehicle, where they operate an awful lot of vehicles out there that have to be DDA compliant and are smaller in type and size, and this is really where the interest in hydrogen is coming from as well, looking at ranges of around 500 kilometers. So using batteries as the main drive with the range extender on the hydrogen. But we have done well in Edinburgh and in Scotland with Orion, really well. We're involved with Flexibus in Gothenburg, where they're running a shorter version of the Orion on a demand responsive service. So there's interest from all over, and it is early days, but bus operators are starting to look at this concept quite seriously now as a way of mixing their fleets and dealing with their different types of demand and the different type of experiences that people are looking for. I think if you could look at Hamburg, perhaps with Moya, where there's been a big uptake in demand responsive on small vehicles with good passenger experiences, but not DDA compliancy, so not really endorsable by public transport and public transport authorities. It's definitely something that's growing very rapidly at the moment. We're starting to see good demand coming.
Great stuff. Okie dokie. Well, we've come to the end of our time. Thank you very much to Greg, Sean, and Steve, as well as Charlie, David, and Mike earlier on. Apologies for some of the audio issues. Hopefully, we'll get that sorted for next time. We've got another webinar on EV bus fleets in a week's time, same time next Tuesday on the 2nd of June. We're going to be looking at park and ride services in York and how First Bus worked with Optare to electrify those. This Thursday, LowCVP's got a webinar looking at the decarbonisation of heavy duty vehicles using renewable fuels. So again, there's a link embedded here, and we'll share the link afterwards if you're interested in renewable fuels as well. And LowCVP will also be hosting our annual conference this year on the 15th of July. So save the date for that. It's free for members. And just to finally finish, if you are interested in joining the conversation and joining some of LowCVP's working groups, please do let me know and we can follow up with a conversation afterwards. But thanks again to all the speakers and thanks to all of you who stuck with us to the end and persevered. So thank you very much and wish you a good rest of the week. Many thanks. Bye-bye.